Today we're going to be starting Chapter 6, which is on rational exponents and radical functions. We're going to be looking at Section 6.1 today, which is on evaluating nth roots and using rational exponents. And our goal is to evaluate these nth roots and study rational exponents. When we talk about nth roots, we're talking about index numbers. And so far we've talked about square roots. Well, today we're going to be talking about like third roots and fourth roots and fifth roots. And so when we look here, it says the nth root of a for an integer n greater than 1. If b to the n equals a, then b is an nth root, which is written as the nth root of a. So if we look at that, the n is our index number. When we talk about the square root, if we see this, we all know that the square root of 4 is 2. What we don't realize maybe is that the index number in this case is a 2. So if you see something that looks like this, the square root of 36, which we know is 6, there's really a little 2 in here because it's called the square root. So if it's a third root, it'll have a 3 in there. If it's a fourth root, it will have a 4 in there. So that's what the index of the radical is. It's the integer n. It's the number that's got to be greater than 1 in that expression. So when we take the nth root of a, we're going to let n be an integer where n is greater than 1. So it's going to be bigger than 1. It's going to be a positive number, and it has to be a real number. So we have a couple of different situations here. If that index number is even, or if it is odd, it means it's going to be two different things. So if it's even and a is less than 0, so we're looking at a situation like this. So if our index number is even, so if this n, the number on the outside, is even and a is negative, that means there's no real nth roots. And we always want to approach this like it's a square root. The square root of a negative number was imaginary. And so that's why there are no real roots in that situation. If it's 0, well, the square root of 0 is 0. The third root, or the fourth root of 0 is 0. So if that a, the number, your radicand, is 0, then it's automatically going to be 0. And if the number inside your square root, your radicand a, is bigger than 0, then you're going to have two real nth roots. And that's going to be plus or minus that. Just like when we have the square root, we had to take the plus or minus of both sides. Okay? So that is if n is an even integer. If we come over here and we have the nth root, and it's an odd integer, well, that's going to be a little bit different. Now, if n is odd and a is less than 0, so let's say we have a negative number in there, then there's going to be one real nth root. If it's 0, again, it's still going to be 0. And if it's positive, if a is positive, now we're going to have, again, one real nth root. So if n is odd, we're always going to have one real nth root unless that number is 0. And we'll look at a couple of examples here. In example 1, we want to find the nth roots. So find the indicated nth roots of a. So here, n is 5, and a is negative 32. So realistically, what they're asking us to do is this. What is the fifth root of negative 32? So they're saying what times itself 5 times gives you negative 32. So if we look at it like that, we could write it in a situation that looks like this. So what number is that? Well, the fifth root of negative 32 is negative 2. All right. And there's only one here because this one is odd and this is negative. So therefore, we're only going to have one real solution. So let's go to the next one where we have the index number is 6. If the index number is 6, that's even, and A is 1, which is positive. If we look back up here, we have even and positive. So we're in that situation. We're going to have two solutions. So this is going to be plus or minus 1. And that should make sense because 1 to the 6th power is 1, and negative 1 to the 6th power is also 1. So we're going to jump down to some rational exponents. And the rules for rational exponents, it says let a to the 1 over n be an nth root of a. Let m be a positive integer. So we're going to look at taking the rules for exponents, and if we have a fraction now as our exponent, we're going to look at how to write that in radical form and vice versa. So we're going to be able to go from rational exponents to radical form and radical form to rational exponents. So notice here we have a to the m over n, and they rewrite it as a to the 1 over n to the m. And then we have the nth root of a raised to the m power. Now notice, your denominator is always going to be your index number. Okay, so your denominator is the index number of your radical, and the other one will be on the outside. That's our power that we're going to raise it to. And the rules for exponents, we have a negative exponent. Again, we can never have a negative exponent, so we move it to the bottom. It becomes positive, 1 over to a to the m, and then we do everything exactly the same. So in example 2, they're going to ask us now to evaluate these expressions with rational exponents. And if we rewrite this like they do in the rational exponents, we can write 125 to the 1/3 power squared. Well, that's really the third root of 125 squared. And the third root of 125 is 5, because 5 times 5 times 5 is 125. And so we have 5 squared, which now that equals 25. We're going to do the same thing with b. We're going to rewrite this as 8 to the 1/3. Actually, let's move it all to the bottom first. So it's going to be 1 over 8 to the 4/3. So now it'll be 1 over 8. Make that a 1/3 raised to the 4th power. So now we write that as the third root of 8 to the 4th. Well, the third root of 8 is 2, because 2 times 2 times 2 is 8. And so we have 1 over 2 to the 4th power, which is 1 over 16. So what we're going to do now is we're going to look at how to use your calculator to find some of these roots. In case you don't know how to do it, well, we want to look at these, and these are rational exponents. We can just type them in just like that. If we want to find the third root of 8, we're going to type it in just like that. So let's get out our graphing calculator. All right, so we have our graphing calculator. We can do this in a variety of different ways. Let's say we have the number in 125, and we didn't know what the third root of that was. So here's what we can do. We can just type that in, 125 to the 1/3 root. And so we'd have 1 divided by 3. Now if your calculator doesn't keep it in the exponent, you might have to put parentheses around 1 divided by 3. But it's 125 to the 1/3 power. You hit enter, and it gives it to us right there. It's 5. If it was the 1/5 power, if we wanted to find, let's say, the 5th root of 32, so that's going to be 32 to the 1/5 power. We're going to raise that, and we would just get, and they would give it to us there. Okay? So that's one way to do it. You can also go into your math button. If you hit the math button, you'll see here for number 4 is your 4th root, and number 5 is the xth root. So you can put whatever it is root in there that you would like to use. So if we want to use, let's say the xth root of something, here's what we're going to have to do. We're going to get out of here. Let's say I want to take the number 81. And I want to find what is the 4th root of 81. So actually what we're going to have to do is we're going to have to put whatever index number we're using first. So I'm going to use the 4th root. I'm going to hit my math button. I'm going to go to the x root, and then I'm going to type in 81, and it'll give me the answer there. So there's another way to use the index, and it just kind of depends whether you like using rational exponents or if you like using radical form, but that's how we can do some of these stuff, or some of these evaluations on our calculators. So what we're going to do next is actually look at just exactly that. We're going to come and use approximating roots with our calculator. So it says evaluate the expression using a calculator, round the results to 2 decimals. So we're going to put 22 to the 1/4 in our graph, in our calculator. So we're going to go 22 to the 1/4 power and hit enter, and it's going to be 2.17 approximately. All right. So that is all we have to do here is go 2.17 because we're going to the nearest, or 200ths. Now, same thing, 35 to the 5/6. So we're going to go 35 raised to the 5/6 power. So let's go 35 to the 5/6 power, and it's 19.35. And then also we're going to do the same thing with the next one. So if we have the 5th root of 11 to the 4th power, you can do that in a couple of different ways. You could put it in as, well, this really means 11 to the 4/5, or you could put it in as the 5th root of 11 to the 4th power. And so let's do it like it as it's written. So we're going to go the 5th root 11, so 5, go down 5th root of 11, and I could hit enter there and then raise it to the 4th power, right? Is that the, yep, to the 4th power. And we're going to get 6.81. So this is approximately 6.81. So what I would like you to do is go ahead and try to do the guided practice questions 1 through 12. So go ahead and pause the video, do those 12 questions, and then you can hit play when you're ready to resume. And here are the answers to the guided practice questions. Notice the numbers 1 and 2, they're both even indexes, so we have the plus or minuses there. And numbers 3 and 4, they're odd indexes, so you only have one answer. Numbers 5 through 8, we change them into radical form. Remember, your denominator of your exponent is always going to be your index number. The numerator of your exponent is always going to be what power you raise that to. And then in numbers 9 through 12, we just plugged those into our calculators and found those answers to the nearest decimal places, to the nearest hundredth. So, All right, now in example 4, we're going to be looking at now using the rules and properties that we've talked about to actually solve equations. And these are exactly the same as when we solved linear equations back in 5th and 6th grade, and quadratics in 8th and 9th grade, and this year, and all of the equations. We're going to do the same thing. We're going to still use our inverse operations, do everything that we normally would, only now we're going to be taking a third root or a fourth root, maybe something like that. So first of all, in example 4a, we want to get the x cubed by itself. Our goal is always to get that variable by itself. So we're going to get rid of the 6. So how do you get rid of that? Well, you divide it. So we're going to have 384 divided by 6. Well, that's going to give us 64. So we're going to have x cubed equals 64. Well, how do you get rid of a cube? Well, you take the third root. Just like if this was a squared, we'd take the square root. Now, since that is an odd index, 3 is an odd number, you are not going to have it plus or minus. If that was an even index, we would. So now x is going to equal, well, the third root of 64 is 4. So that is your answer. Okay, so the third root of 64 is 4. Now, you can always check to make sure you plug it in, it works. Put it in. 4 cubed is 64. 64 times 6 is 384. So that is our solution. All right, jumping over to example B. Notice everything on the left side is raised to the 5th power. So what we're going to do right away is take it the 5th root of both sides. Okay. And again, 5 is an odd index, so we don't have to, oops, forgot to put my 3 in that one. So 5 is an odd index, so we're taking the 5th root of both sides. So now the 5th root of x minus 8 to the 5th, well, the 5th root and to the 5th power cancel out, so we're left with x minus 8 here, and this is going to equal the 5th root of 100. Well, there are no numbers that come out evenly as a 5th root. You plug it into your calculator. You go to the 5th root of 100. So let's do that. Let's go, what is the 5th root of 100? So 100 to the 1/5 power. And it's 2.5, approximately 2.51. So let's put that in there. So we're going to get x minus 8 is approximately 2.51, and now we add 8 to both sides, just like we normally would when solving our equation. So x is going to equal approximately, so we're going to say it's approximately 10.51. And notice in example 4, we need to make sure to put these third roots in here. I forgot to do that right when I did it. I talked about it, but I forgot to write those in there because we're taking the third root. All right, jumping down to example 5. It says the nth root in problem solving. An exercise ball is made of 7,854 square centimeters of material. Find the diameter of the ball. Well, they tell us that the surface area of a sphere, which is what our ball is 4 pi r squared. Well, they give us what that is. So it's 7,854 equals 4 pi r squared. So what we're going to do is we're going to solve those. Well, our goal here obviously is to get the r by itself. So we're going to divide both sides by 4 pi. So you're going to type that in your calculator, 7,855 divided by 4 pi, and you're going to get, let's move it over here, you're going to get 625 approximately equals r squared. Okay, so this approximately 625 is just a little bit off because pi is, depends on what value you use for pi. So now we have a square root. So I'm going to take the square root of both sides. And the square root of 625 is plus or minus 25. Now remember, because we had the square root, which is a 2, is an even index, we have to have a plus or minus there. Okay. Now, in this case, our radius is not going to be negative 25. So r is going to equal 25. The question says find the diameter of the ball. So if the radius of this ball is 25 centimeters, what is the diameter? Well, the diameter is twice as long as the radius. So we're going to say the diameter of the ball is 50 centimeters. So now we're going to jump down to some of the guided practice questions. So go ahead and solve some of these. I will do all of them, solve the ones that you want. If you want to do a couple of them, you can. Some of them are a little bit similar, some of them are a little bit different, but go ahead and pause the video, and then you can hit play when you are ready to resume. And here are the answers that we get when we solve the equations in the guided practice 13 through 18. And once again, remember, if that index number is odd, or if you're taking an odd root, like a third, a fifth, a seventh, you don't have to have your plus or minus. You're only going to have one solution. So notice in 13 we had an x cubed. In 14 we had an x to the fifth. In 16 we had an x cubed. In 17 we had an x cubed. Notice in those 4 problems we only had one solution. However, if you look at 15 and 18, where those index numbers are even, we had a square in 15 and a 4 in 18. Those powers are even. So when we take the roots of an even, we had to have our plus or minus, and that's why we have 2 answers in 15 and 18. So the biggest things to remember from this section are how to solve these equations using rational and radical exponents. Remember, the index number in your radical comes from the denominator. So if I have something that looks like this, where we have x to the 9/5, you can rewrite this in radical form as the 5th root of x to the 9th. Notice this exponent, the denominator, is always your index number, and your numerator is always the power it's going to be raised to. Right. So again, in section 6.1, we're talking about evaluating nth roots and using rational exponents to solve equations. So here are the 2 homework sets that you can choose from.